This is a video for OCR Pure Core Mathematics, Calculus 4, Integration Techniques, 4.5, substituting x equals a sin u or x equals a tan u. We've already seen how to use these two substitutions in certain types of integrals. They can be generalized to x equals a sin u for expressions involving the square root of a squared minus x squared, and a tan u for expressions involving a squared plus x squared. Let's look at this example. It's the square root of 25 minus x squared. Think of that as 5 squared minus x squared. So I'm likely to want to use a substitution of the form x equals 5 sin u. I've also got limits, so I need to remember to transform those. Well, if x equals 5 sin u, then differentiating I get that dx by du is equal to 5 cos u. And so when I'm substituting for dx, I will put in 5 cos u du. I need to consider the limits as well. When x equals 5 over 2, I've got that 5 sin u is equal to 5 over 2. And so that's going to give me that u is equal to pi by 6. Sin u is a half. I've also got x equals 0. 5 sin u equals 0. So u equals 0. So these are the two limits that I need to transform into. I've now got everything I need to do the substitution, so this integral is going to become the integral between 0 and pi by 6 of the square root of 25 minus 25 sine squared u, and then the whole thing is times 5 cos u du. 25 minus 25 sine squared, well, the 25 can come out as a common factor, and as it comes out through the square root will become just a 5. So that's going to be the integral between 0 and pi by 6 of 5 root 1 minus sine squared times 5 cos u du. 1 minus sine squared is cos squared, square rooted is cos, so I've actually got 5 cos u times 5 cos u here. So this thing is actually the integral between 0 and pi by 6 of 25 cos squared u du. Now, we've seen how to integrate cos squared in a previous video. We use the double angle formula, cos 2u is equal to 2 cos squared u minus 1, and rearrange that. So this thing becomes 25 over 2, remember we get a half from that double angle formula, and then we're going to get cos 2u plus 1 du. So now we do the integral. I'm going to get 25 over 2. Integrate cos 2u. I get a half sine 2u plus u. And that's between 0 and pi by 6. And plugging in those values, I get 25 over 2 times a half of sine pi by 3, this will become, is going to be root 3 over 2. So I'm going to get root 3 over 4 in there, plus pi by 6, and then 0, sine of 0 is 0, and of course u is 0, so I get that. So my final result looks to be 25 over 2 times root 3 over 4 plus pi by 6, which I could write as 25 over 4 root 3 over 2 plus pi by 3. This is it tidied up. There's the substitution. There's the transform of the limits, and don't forget those. And then work it through as I did on the previous slide to get the final result here. Okay, so in this example, I've got an integral written here, and I want to rewrite it here. There's obviously some type of substitution gone on, so I need to work out what that substitution needs to be. Starting with our original integral then, I'm going to get the integral of 1 over 1 plus 9x squared to the 3 over 2 dx. And the issue I've got in here is this 9. I'd like a coefficient of just 1 for x squared, so I'm going to take out a factor of 9 from this bracket. As it comes out of the bracket, it's going to be affected by a square root, making it 3, and then a cube, making it 27. So this becomes 1 over 27, the integral of 1 over 1/9, remember it was 9 I took out, plus x squared to the power 3 over 2 dx. Now there's a lot gone on there, so just make sure that you understand what's happened. And the other thing to note is here, if I think of that as an a squared plus x squared type thing, 1/9 means that with a equals a third, that is a squared plus x squared. So my substitution feels like it should be 1/3 tan u. Differentiating, I get that's 1/3 sec squared u. So I'm going to get 1 over 27 times the integral of 1 over 1/9 plus 1/9 of tan squared u. That's all to the power 3 over 2, and that's multiplied by 1/3 sec squared u du. Okay, so this becomes 1 over 27, the integral. Let's think about what I've got in here. I've got 1/9 of 1 plus tan squared, so I've got a 9th of sec squared on the bottom. So that's 1 over 1/9 of sec squared u to the power 3 over 2, and that's times 1/3 of sec squared u du. Moving that on then, still got my 1 over 27 outside. 1/9 of sec squared, well this is going to square root it, this bit here is going to square root the 9th sec squared, so that'll give me a 1/3 sec, and then this bit will cube it, so that will give me 1/27 of sec cubed. So I'm dividing by sec cubed u over 27, which means in here I can get 27 over sec cubed u. That's multiplied by sec squared u over 3, du. And you can see here there's a fair amount of cancelling that can be done. I can cancel off the sec squared at the top here with 2 out of the 3 secs in the power down here. The 27s will go, and I am left with 1/3 the integral of 1 over sec u. And we have seen before that that's just 1/3 the integral of cos u du as required. There's that worked through for you. Be very, very careful with these fractions and the power 3 over 2. Always think about it in 2 stages, square root and then cube. And you can see everything works through to get me down to 1/3 cos u. Okay, let's pick up from here then. I'm integrating 1/3 cos u du, and that just gives me 1/3 sine u plus a constant, because of course we've got an indefinite integral. That was relatively easy. The difficult part is getting back to an expression in terms of x. I know that x is equal to 1/3 tan u, and therefore that 3x is equal to tan u. I also know that sec squared u is equal to 1 plus tan squared u. And so sec u is equal to the square root of 1 plus tan squared u, and that is the square root of 1 plus 9x squared. That means that cos u is going to be 1 over the square root of 1 plus 9x squared. Now, how do I get sine u? Well, sine u can be got from tan u times cos u. Remember that tan is sine over cos, so they would cancel off. Well, I know that tan u is 3x, and that cos u is 1 over the square root of 1 plus 9x squared. So that tells me that sine u is equal to 3x over the square root of 1 plus 9x squared. I've now got that my integral, which came out at 1/3 sine u plus c, substitutes back to 1/3 of 3x over the square root of 1 plus 9x squared plus c. And so that just gives me x over root 1 plus 9x squared plus c. Okay, there's my working. There's the integral. As I said, that was the easy part. Here's the working through to work out what cos u and therefore what sine u is. And so we can get our final result. So in summary, we've used x equals a sine u here in expressions involving this root a squared minus x squared, and x equals a tan u in expressions involving a squared plus x squared. The resulting integral may need further techniques, and we have used quite a few techniques, but in particular the use of the double angle formula we saw in the first example. The other thing we saw was that transforming back to the original variable may take some care. And finally, definite integrals need to have their limits transformed. That was the final video in the sequence Calculus 4 Integration Techniques.